Hello everyone, in this video I'm going to talk about distance time graphs. But before we do that, I want to talk about some definitions. So in general, by the time you are in year 9, you should know the definitions of speed, distance and time. So now speed tells us how fast something is traveling. The greater the value, the faster it's going. If you are in Australia, you would use kilometers per hour. If you are in America, you would have said miles per hour. So it depends on the units that you are using in your country. Distance is the amount of space between 2 points or 2 places that an object covers as it moves. So distance from your house to school, again, units would be kilometers or miles. Now time is the period it takes to travel a certain distance. So it can be hours, minutes or seconds, right? The time that you will take to reach your destination. Now the other important connection between speed, distance and time is speed is always equal to distance over time. Now let's do some check for understanding. If a cyclist is traveling 60 kilometers in 3 hours, what is their speed or what is his speed, right? The formula is distance over time. If you want to know the speed, so he covered 60 kilometers in 3 hours. So that means his speed is 20 kilometers per hour. So that means he's able to finish or cover 20 kilometers per hour. Now I really liked another triangle, speed, distance, time triangle. They call this as DST triangle. So you can remember daylight savings time, or there are some other acronyms that people use it, but it's a DST triangle. The reason it should go in this order is the D has to be in the top space, S over here, and then T on this side. So distance, speed and time. So the placement of these words are important. So distance is D, speed is S and time is T. Now rearranging the formula is a difficult technique, and people do struggle in classrooms. And if you are struggling, that's why this acronym can help you. So D, if you want to know speed, so highlight the speed, right? You're looking from speed. So D is in the numerator and T is in the denominator. So D over T. That means speed is distance over time. But if you are trying to find the distance, the other two letters, which is S and T, are next to each other. So all you have to do is write speed times time. Okay, so S times T. Now whereas when you're looking for time, you highlight your T, right? So then you have D in the numerator and S in the denominator. So D over S. So time is always distance over speed. Now DST, daylight saving time, is a very good way to remember this. Okay, so thanks to Third Space for creating this slide, but that's where I'm taking it from, but it's quite helpful for you to remember. Now if you move down for the next example, I'm going to talk about how to plot these distance time graphs. Okay, so distance time graphs have some special features that you need to understand. So the time should always be on x-axis. The distance is going to be on y-axis. Now, unlike any other graph, here you will see some variations in gradients, right? So sometimes it can be too steep, sometimes it can be flat, sometimes it can be downwards line, it can be stationary. So what does all these mean? I'm going to quickly talk about it. Now if a line, so this is a start of your starting point. Now if you are going away from your starting point, you would represent it with a line that is going upwards. Now it depends on your speed, whether based on the steepness of the line, whether your speed is higher or lower will decide. Now when you have a flat bits in your graph, that means it is stationary. A good example is if you are planning a road trip, if you have taken a restroom break or a restaurant break to eat something or to fill up gas, your car is not moving, so that would be the stationary part. Now if a line is going down, that means you're trying to get back to the original place. So that's why as you're moving downwards, you're trying to get closer back to your destination. Now if you're moving again, if it gets any time up, it means you're moving away from your point. Okay, so if you stop right there, that means that's where your destination is. If you're trying to come back to the original spot, this line would come down. Okay, so we'll do some examples to understand what I mean. But in the midst of all this, there's this distance, this time, but where is the speed, right? So DST, our three related terms, one of them is missing. So how could I find that? So that's the tricky part in this DST graphs. So you should remember that your gradient or slope is always rise over run. So if you do the distance over the time, you are indirectly finding the speed. I repeat that again. So we know that the change in y over change in x, which is our gradient, rise over run, is actually helping us in this scenario to find speed. Okay, so steeper the gradient, that means you're moving faster. If the line is going down, that means it's coming to the starting point, and or you can assume that it is traveling back towards the starting point. Now if the graph is flat, the object is stationary, right? So this is what our understanding is. Because there's no change in speed, the line should be stationary. If you are trying to head back to where you are, the line would be represented going down. Okay, all right, so we can easily calculate our speed by putting the distance over time, right? So let's take a quick example here. Hillary sets out from home to go to a friend's house. She runs for a while and walks the rest of the way. After playing with her friend, she then travels home again, running part of the way, then stopping to pick flowers for her mom. And here is a time distance or distance time travel graph showing Hillary's journey. So I have time on my x-axis, and then I have my distance on y-axis, and it is, the unit is given in meters. So you can see that this person, the line is a bit steeper compared to this one, and then there's this flat bit for a very long time, and then the line is steeper again coming down. There's a flat bit and then again coming back. So if it's touching back the x-axis, that means she has returned back to where she started from. So that means in this case she returned back to our home. So now there are a couple of questions based on this particular graph. So let's see whether we are able to interpret the data. How long did it take Hillary to get to her friend's house? So in order to assume her friend's house where she stayed for a long time, it is right here, this point. So if you see that particular point right there, from 9 to 9:30, how long? That would be 30 minutes. So C is the right answer. For how long did she run on the way to her friend's house? So running, so if you see in the original question when I read, she runs for a while and then walks the rest of the time. So by seeing these two points, because this line is steeper, I'm assuming that this is the running bit. So if you see for how long did she run on the way to her friend's house, it have to be right here. So I would assume that would be from 9 to that particular point right there. So that would be roughly 10 minutes. So I would go with 10 minutes. Definitely not 3 minutes, nor 30 minutes. That 30 minutes is the total time to get to her friend's house. So A is the right answer. At what time did Hillary arrive at her friend's house? So if you see before the start of the stationary part, that is 9:30. So the right answer should be C. At what time did Hillary arrive at her friend's house? Oh, did I repeat that question? My bad. Okay. How far did Hillary travel to get to her friend's house? I'll give you some think time, guys. So how far did Hillary travel? So now how far should be the y-axis part that you need to look at, distance. So this is the start of her house. So she's from 0 going all the way to 350. So 350 meters is the right answer. What was Hillary's average speed on her journey to her friend's house? So speed is calculated with the formula distance over time. So the distance is 350 meters over 0.5 hours, because you need to remember that from 9 to 9:30 that is 30 minutes, but your answer choices are in terms of meters per hour. So 350 divided by 0.5, that would be 700 meters per hour. Two more questions, guys. How far was Hillary from home when she stopped to pick flowers? So remember, she stopped a little bit on her way back, and that would be this part right here, from 11:15 to right here. That is for just, so 11:15 is here, 11:30 is here, so that means this is 15 minutes. So roughly that part is, so the question is, how far was Hillary from home? Okay, so right here, that is, she's roughly 150 meters away from home. So that's when she stopped to pick up her beautiful flowers, and she stopped, and then she started again. Estimate the time for which she stopped. So I see that roughly, so this is 15 minutes. So more than half time she stopped. So we can say 7.5 to 8 minutes. So I would go with answer choice B. So that's all from my side, guys. So this is Hillary's travel graph using distance time graph analysis. Hope if this was helpful for you guys to analyze the graphs. Check out some more videos to understand speed, distance, and time relationships. Thanks again. Thanks for watching.